So now I want to go over to Sabtain. Sabtain Khan is lead product manager for IBM Watson Visual Recognition. And he works across all aspects of Watson's products, but he works directly with companies on implementing their technologies as well. And today he's sharing some background on Watson, as well as some early results from a new custom system that's built sort of specifically to demo for our industry. So I'll turn it over to Sabtain.
Hi, so as Tom mentioned, I'm Sabtain. Thanks for having me. And, Georgie and Virginia, thanks for giving a lot of background around AI and computer vision. Saves me some of the headache to go through all of it with you guys. And IBM Watson is a collection of different AI capabilities, and it's highly competitive, and we do everything from computer vision to understanding text to doing search on documents. And within vision, we do everything Google does, right? And we do everything the rest of the industry does. We understand what's in an image. We understand explicit content. We help you build custom models to look for very specific things. And I'm going to talk a little bit about each of these and actual customer application. So we have a customer who collects a lot of images, and they're all images that they own and images that they scanned in social media profiles. And they are working on a way to help create a better way to target advertisements towards their users. So they take, and this is like the most typical social media post you can probably find, they take those photos, understand the content. In this case, we would classify this as nature, hill, traveler, mountain range. And then the text is something we actually look at also. I don't think it's showing up over there. It's probably a font issue, but we understand the text as similar travel psychology, right? So we extract that info from the content the user posts, and then our client actually puts together something in their application to help advertisers better understand who that user is, and then send them ads for things like Filson backpacks or travel gear. So it's important because we are trying to understand these sort of things from all kinds of photos, whether it's archival photos within our news agency or our media website, or whether it's a newspaper looking for something online and wants to understand like what is in this image. It's important for a decision that needs to be made afterwards. Another example is building a custom model to detect something very specific in an insurance industry. So with Watson, you can use data you already have. Insurance companies have a lot of case and incident reports with images already in there. They upload those images and they label those images as this is a car with a damaged bumper, this is a car with a bumper that has no damage, whether it's a side panel, whether it's a mirror, flat tire, etc. And this customer actually trains a model and then deployed an application for their users to take an image after an accident and send it to them, fill out some other information like their license plate number, their plate, model, make, year, etc., and combine that information in their application to come up with some sort of estimate so that they can give the user a quicker route to getting their car to an auto repair shop and get it back to them afterwards. For things like fender benders, which are like 95% of most accidents, this helped them move their more complicated insurance use cases, like more complicated accidents, higher value sort of things as well, to actual adjusters on the field. So it really helped offload all that petty sort of like insurance adjusting to higher value. Like I need to spend my adjusters who I need them to extract the most value out of the work that they're doing. So let's enable the customers to actually go and take the photos and find their estimates rather than those adjusters who we pay a lot for. This is really cool. We've been, I want to see if I can get the video to show up here. So we've actually created apps for auto manufacturers, and we help them train models to understand whether there's defects in cars. This technician is doing a quality assurance job trying to understand if there's a defect with a lug nut over here or with welds. And what's really cool about this is that they've actually taken taken it from going through the phone to putting up harnesses within assembly lines and running their assembly line to see if something within the line actually ends up causing an alarm that, oh, this like underbody of the car is missing this application of glue, like alert the floor manager to come and make a change to the assembly line, fix the issue to increase throughput and stop major blockers from actually producing these cars. They've made it even more amazing, so now they can actually look for other problems from a console and be able to say, well, there's other problems that are coming up, let's label those too. So they've kind of created this like loop to help them capture more images, label more images, and look for more issues on their production line, and then alert managers when there is something that pops up. Again, like their biggest thing is how do we stop ourselves from like wasting resources? How do we enable technicians faster so they can do things on the ground, do quality checks faster? And as Tom mentioned, we recently released something that allows us to do custom object detection. And I know Georgie and Virginia spoke about this too. We're making it really easy for users to use a tool, label objects, and understand what's on the object. In this case, I'm a geek, so I love like looking at motherboards. And I didn't even use 20 images to do this, and I just labeled a few things here, like the CPU, the RAM slots as a whole, and the PCI slots. I also labeled other things like our power supply, plug unit, and the CMOS battery. And after doing that labeling and training a model, it didn't even take 25 minutes. I had something that can detect something at this level. So it's pretty incredible like how quickly you can start detecting for things in different images in different types of industries. More relevant to media images are like finding people, finding obstruction in images. I made this model on my own using Watson. It wasn't even 30 images that were into the model. And you can see that middle image. We were able to find so many people within that photo. Now imagine you expand this to other obstructions in images, like there's a cone in one image, there's helmets, there's other things. How do you find those and locate them, and then how do you understand whether or not that person is visible or not visible? Are they facing the camera? Are they facing away from the camera? Is that person, somebody needs to like sign a release form? Is that person somebody that's, like obstructed in some way, so you can avoid that? There's a lot of other applications of this. And I think it's important to note that what we give you are the tools you need to make the next decision within your application or within your business problem. Another thing that I love is that we made it really easy to label. I mean, you can draw boxes, but once you've trained a model, so this is how you would like actually label, right? You draw a box, I adjust that box a little bit to get the sizing correct, and I move on. And I do that for everything in that, and I do that maybe 20 times for 20 different images, and now I have a computer vision model. But what if I have hundreds and thousands of images, and I want to strengthen that model so it's as accurate as possible? Well then, we made it really easy so that after I've done that, I just make it so you can hit auto label, and now I've tagged that image. So, and we're working on doing this so you can do it in mass, and we're working on making it even simpler to label your images so you can really build a custom model faster, which is where like so much of the power is, because use cases are usually custom and not general in nature. So I'd love to talk more after and at the panel, or if you have just questions later as well.
Awesome. Yeah, thank you. Yeah, I think where we see Watson being most valuable to us in the stock licensing industry is, like you showed, you can come up with a concept, whether that's looking for copy space in your images, looking for a particular client's brand, looking at a particular kind of car, and even without having a team that can do the kind of computer vision work to train a model, you can actually do it with this sort of drag and drop interface and identify what matters to your particular slice of the stock media licensing industry.